Hello everyone, this is Manohar Reddy, Assistant Professor, Department of Cyber Security, Institute of Aeronautical Engineering. Today I am going to discuss about the next concept, key constraints in DBMS. Key constraints in DBMS. In the last sessions we discussed about different types of ACID properties, different types of database softwares, different types of data models, architectural components and all. So in this session, we are going to know about the key constraints in database management system. So in regular basis, we are applying some rules or specifications or constraints or conditions. You can say anything, rules or specifications or conditions or constraints in our regular basis we are maintaining, right? So in the same way, database also maintaining some certain conditions or specifications or rules. So what are the conditions? We can also call it as constraints. We can also call it as constraints. So how you are going to apply constraints in database? In this session we are going to know. So the first one is what? So key constraints. The constraint in MySQL is used to specify the rules. Specify the rules that allows or restricts what values or data will be stored in the table. So to store the data, to store the tables in the database, we are going to apply some rules and specifications or conditions or constraints. You can say anything. So that all are nothing but constraints. So applying rules or specifications or conditions is nothing but constraints in database management system. So that constraints or that conditions provide a suitable method to ensure data accuracy and integrity inside of the table. So to maintain that data accuracy and maintain that integrity of the data, we are going to apply the constraints. We are going to apply the constraints or conditions. So it also helps to limit the type of data that will be inserted inside of the table. It also helps to limit the type of the data. So which type of the data is to be going to store and which is a type of condition, and that all we have to see. So for that one we are going to use these constraints. For that one we are going to use these constraints. So what are the different types of constraints we are going to apply in the tables or database? So definitely we can say that first of all we have to create the database. After then we are going to create the tables. After that only we are going to create the tables, right? So we can apply the constraints to the tables. We can apply the constraints to the tables, and a table also can have columns also. Tables can have columns. So columns are also called as attributes also. So columns are also called as attributes. So we can apply the constraints or conditions to the tables. We can also apply the conditions or constraints to the columns, but we cannot apply the constraints to the database. We can apply constraints to the tables or columns, but we cannot apply constraints to the database, right? So we are going to create the tables. We are going to create the different database objects. So different database objects we have created in the database. For that all the database objects, we are going to apply the constraints. So constraints are nothing but specifying the limits of the columns or table values. Specifying the limits of the columns or values. So we are going to specifying the conditions. We are going to specifying that limitations for the table values. So table values. So we are going to apply constraints in the two ways. One is what? Column level constraints, and the second one is what? Table level constraints. One is what? Column level constraints, and the second one is what? Table level constraints. The name itself, table level constraints. The name itself, column level constraints. So column level, these constraints are applied only to the single column that limits the type of a particular column data. So that means column level constraints are applied to the single column in the table. You can apply condition or specification or limit to the column in the table. Not all the columns, only single column you can apply. But for the table level constraints, these constraints are applied to the entire table. That limits the type of data for whole table. So table level constraints are nothing but you can apply the constraints entire the table. Entire the table is nothing but indirectly you are going to say that all the columns having the constraints, all the columns has to be applied with the constraints. All the columns has to be applied with the constraints. Only one column is applied with the constraint is nothing but column level constraint. All the columns will be applied with the constraints is called as table level constraints. That means indirectly we are saying that we can apply the constraints to all the columns. We can apply the constraints to all the columns. All the columns means indirectly you can say the table. So that's why you can say the table level constraints. And these are the column level constraints. Column level constraints. So we can see how column level constraints are applied and how the table level constraints are applied. So we'll see there are different types of how to create. First of all, how to create constraints in MySQL. How to create constraints in MySQL. So we can create the constraints depending upon the table creation. So how you are going to create the table itself only, we are going to apply the condition. So see here, we can define the constraints during a table created. So while creating the table itself only, we can create the constraint. So created by the using create table statement, we can create the constraints with the help of create table statement only. So MySQL also uses alter table statements to specify the constraints in the case of existing table schema. We can apply the constraints while during the table creation, as well as we can create the constraints after created of the table also. So that is we can specify with the help of alter command. So we can construct the constraints at the time of table creation, as well as altering the table also. So there are different types of constraints you can apply in the tables. So what are the different types of constraints? Most of the used one and most of the common constraints we can see here. So not null constraints, check constraints, default constraints, primary key constraints, auto increment constraints, unique constraints, and foreign key constraints. So these constraints are apply the limitations to enter the data. Or to do not enter the data. Apply the limitations to enter the data or to do not enter the data. When you are specifying some certain constraint, you are entering more data. When you are specifying some constraints, you are not going to enter more data. So like the way you are going to apply limitations to creating the data in the table. We'll see how the constraints are applied to the table level or column level. We can see here. The first one is what? So see here, first one is what? Not null constraint. So not null constraints. This constraint specify that the column cannot have null or empty values. The below statement creates a table with not null constraint. We'll see. So not null constraints, that means indirectly we are applying that not null constraint on one column. That column is not going to have any empty values or null values. It is not going to have any empty values or null values. Definitely it should have some values. So we'll see the example here. Create table student. Student is the table name, or you can say that entity name, and ID is represented with the data type integer. and the last name is represented with the type of data type text, and here we are applying the not null constraint, and also first name text, first name along with the data type text is having not null data type, not null constraint, and the city varchar data type. So in this table we are creating not null constraint for the name, last name and first name, for the last name and first name. For these two column names we are applying a not null constraint, that means indirectly we are saying that last name and first name should not be empty. First name and last name columns should not be empty. It should have some values. That means you are going to enter some values means. So not null, if you apply that not null constraint to the particular column, definitely you are going to have some values for that column. You have to enter some values for that column, right? And remaining city and ID, it doesn't specify with the not null values, not null constraint, so that those two columns can have empty values also. But specified columns, not null constraint specified columns doesn't have null values. Definitely they should have some values. So see here, insert into student values of student values. ID is 1 and first name, last name is Hanks, and first name is what, Peter, and the city is what, New York. So it directly we are specifying these values to have some data. And second, see here, insert into student values of 2 comma null comma Amanda comma Florida. So here we are specifying last name as null. Now last name as null. If you are specifying like that, see it shows some error. What that error will show. From the above syntax we have to mention some value instead of null. Otherwise it shows the error like the column cannot be null. It shows the error like what? Column cannot be null. Column cannot be null because you are specified not null constraint to that column. So that's why that column should not have an empty values, or could not have column to be null. Right? It should have some value. At the same time, if you are specifying not null to the ID also, not null to the city also, specifying not null constraint to the ID also and the city also, that means indirectly you are applying not null constraint to all the columns. Suppose ID integer not null, and the text name, last name text not null, first name text not null, city varchar also not null. Like that you are specifying that not null constraint to all the columns, means you are saying that indirectly it is a table level constraints. Because table can have all the columns. So indirectly all the columns are applied with the constraints. All the columns are applied with the not null constraints. So that we can say that it is a table level constraint. If you are not specifying that ID and city varchar with the not null constraints, means this is a column level constraint. So when you are applying inserting values here, if you are specifying null or empty space, then it is showing that error like column cannot be null. That means indirectly it is telling that you have to enter some values. So like that you can understand this not null constraint. And the next one is what? Unique constraints. So this constraint ensure that all the values inserted into the column will be unique. It means a column cannot store duplicate values. That means your column cannot have duplicate values. That means it is saying that you should maintain some unique values. unique values, not having any duplicate values. It does not allowing duplicate values. That means, right? So we'll see. So the syntax is what? A create table shirt brands. This is the table name, ID integer, and a brand name varchar unique. So we are specifying this constraint, unique constraint, to the brand name column. We are specifying unique constraint to the brand name column. So that means the brand name column cannot have any duplicate values. Cannot have any duplicate values. And the last one is what? Size varchar. Size varchar. So here varchar integer are the data types. Varchar integers are the data types. So in this example, in this syntax, we are saying that the brand name column is applied unique constraint. Unique constraint. That means indirectly we are saying that brand name column can have unique values. It doesn't want to have any duplicate values. So see here example. Insert into shirt brands. ID, brand name, size. Values are 1, pantaloons, 38. You can insert the values, multiple values at like this way. You can separate with comma and you can enter multiple values here. So one value is what? One row is, this is one row and this is second row. This is the second row. So one row is having 1, pantaloon, 38 values, and second one is 2, Peter England, 40 size values. Right. Similarly, you can insert one more values. Insert into shirt bands of ID, brand name, size, values of 1, Raymond, 38, and the second one is second, Peter England, 40. So that means now what it will shows actually, we are applying a unique constraint to the brand name column. So here brand name is what? Pantaloons, Peter England, Raymond, Peter England. But we assume that brand name is what? Unique constraint. So, but we are entering the duplicate values also. So at that time what it will shows, we can see that the first insert query executes correctly, but the second statement fails and gives an error that says duplicate entry cannot able for key brand. Duplicate entry cannot be able for key brand. So here the name is what? Peter England. Peter England is the duplicate entry. Is already having in the first row, but you are trying to enter duplicate value again. It like the way it is showing that duplicate entry Peter England for key brand name. So duplicate entry we are entering. So like that it is going to be show the message to you, right? So we are applying unique constraint to this brand name. Similarly, if you are applying unique constraint to the size also, then you have to specify the size unique to be all the brand shirts. So, like the way you can understand this unique constraints, right? And the next one is what? Check constraints. So check constraints what? So it controls the value in particular column. It controls means it is going to be having multiple values, right? But among that multiple values, if you are specifying the check constraints, it maintains some limit of the values. So it ensures that the inserted value in a column must be satisfied with the given condition. So here we are specifying the condition with a given condition that column should be satisfied. In other words, it determines whether the value associated with the column is valid or not with the given condition. So it is going to be validated whether the condition is to be validated or not. So after validated, it is going to be inserted. If it is not validated, the inserted value is not going to be inserted. The inserting value is not going to be inserted. So we'll see example. So here I am going to create the table. Create table persons. ID integer not null constraint. Name varchar not null constraint. And age integer check constraint. check constraints, check age greater than or equal to 18, age greater than or equal 18, semicolon. So in this table, if you are observing that not null constraint is applied to the ID column, and similarly not null constraint is applied to the name column, and check constraint is applied to the age column, so that indirectly you can say that it is a table level, constraints, table level constraints means in the table columns, on the table all the columns having constraints, so ID is not null constraint, and the name is not null constraint, and the age is check constraint. That means ID and name columns doesn't have any empty values. It should have some values, and the age is having the values with the specified condition. That condition is what? Age greater than or equal 18. So we'll see the example. If insert into person's ID, name, age, the values of 1, Robert, 28, 2, Joseph, 35, and 3, Peter, 40. So this is the first record that you are entered, and this is the second record that you entered, and this is the third record that you entered. So now the table having 3 rows, and similarly I am going to enter one more values like 1, Robert, 15. 1, Robert, 15. So the age column can have the values 28, 35, 40, and 15. Age column can have the values what? 28, 35, 40, and 15. Among these all the 4 values, the age column 28 is satisfied with this condition, and 35 is also satisfied with the condition, and 40 is also satisfied with the condition, so that all these 3 records were inserted. But now I am trying to insert what? With the age 15. It is showing some error message. So we'll see. We can see that the first insert query executed successfully. But the second statement fails and gives an error that says check constraint is violated for key age. It is showing that check constraint is violated for key age. So for the key age column is violating with the condition. So that's why you can enter the value is age greater than or equal to 18. With this condition only you are going to allow to enter the values. Enter the values. After this condition satisfied only, all the values to be inserted. Right. So this is the way you can understand the check constraints. You are applying a conditions to enter the values. For the columns. You can apply these check constraints not only for the age, you can apply for the name also. Right. So like the way you can understand this check constraints. And the next constraints is what? Default constraints. So default constraints. This constraint is used to set the default value for the particular column. So we need to set the default value for the particular column where we have not specified any value. It means the column must contain a value including null also. So if you want to enter the default value as null, you can enter. If you want to enter some value as a default, you can enter that value as to be default. So see here we are assuming that we are going to create a table called persons. In that persons, the ID is the first column, is having not null constraints, and the name column is having not null constraints, and the age column is doesn't have any constraints, and the last city column is having default constraint. So that means indirectly we are saying that In this all the columns, if you are specifying some values to this all the columns, but you are not going to specify any value to the city, because we are assuming, we are applying that default value is New York for the city column. Default value is what? New York for the city column. So at that time, what will, how it is showing means, see here, this is the ID column, this is the name column, this is the age column, and this is the city column. So if you are applying some values like ID 1, 2, 3, name some Raj, Ran, and Sam, and age 28, 38, 48, the city must be the default values, because we are applying a default constraint to this city column. We are applying a default constraint to the city column, so that this all the city is New York, New York, New York. So we don't want to enter separately with this, with like this, right? So we don't want to enter a city as a separate column, city as a separate column values, because we are specifying that city as a default constraint, specifying that city as a default constraint. So like the way you can understand this default constraint, right? The next constraint is what? Primary key constraint. Next constraint is what? Primary key constraints. So primary key. So primary key is nothing but it is a role, or it is a role, or it is a process. You can understand that it does not have any duplicate values, and it does not have any null values. It does not have any duplicate values, as well as it does not have any null values. So see here, this constraints is used to specify each record in a table uniquely. Each record in a table uniquely. If the column contains a primary key, if the column contains primary key constraints, then it cannot be null or empty. It shouldn't have any null values. It shouldn't have any empty values. It should have some values. And a table may have duplicate columns, but it can contain only one primary key. So duplicate values also not applied. So by using this primary key, you can allow some values, as well as that values to be unique values. That means it is not going to allow you to enter duplicate values. It is not going to allow to make empty of the columns. So columns doesn't have any empty, and the values columns have values also duplicate. Doesn't have any duplicate values. So we'll see here. Create table persons. ID space integer is the data type, and the constraints are what? Not null and primary key. There are two types of constraints we are applying for this ID column. It should have some values, not null values, and it should have primary key. And the name varchar also it is not null values, and the age also integer, and the city is also varchar. So here we are applying primary key constraint for ID column. So that ID column shows that all the values are non-duplicate values, as well as it should have some values. Right? We'll see example. So suppose insert into persons of ID, name, age, city. The values are 1 Robert, 15 Florida, 1, 2, 3. So these 1, 2, 3 are the IDs, right? And suppose if you are entering like 1, Stephen, 15, Florida, it displays some error, that is you already entered a duplicate value. It is showing that it does not allow to enter duplicate value, because 1 is already inserted with the Robert 15 Florida, but you are trying to enter again a duplicate value with the column value having 1, so that it is displaying with the error like duplicate entries are not allowed with the primary key. So that you will get the message like this, right? So this is all about primary key constraints. So primary keys are used to apply the constraints for do not allowing duplicate values as well as maintaining some not null values. Maintaining some not null values means it doesn't have any empty values. It doesn't have any empty values. The next constraint is what? Auto increment constraint. Auto increment constraint. So auto increment constraints. So this constraints automatically generates a unique number. Automatically generates a unique number whenever we insert a new record. Whenever we insert a new record into the table. So whenever we insert a new record into the table, it automatically increments the numbers. It automatically increments the numbers. Generally, we use these constraints for the primary key field in a table. So when you are specifying the primary key field, in default it is taking as a numbers. It is taking as a unique numbers because primary key is what? It does not allow duplicate values and it should maintain some not null values. So same way here auto increment value specifies that incrementing of all the values. So we'll see the syntax. So create table animals and this id int not null auto increment id data type is what? Integer, and the constraints are not null and auto increment. Constraints are what? Not null and auto increment. So name is what? Not null constraint, and the primary key is what? ID. Primary key is what? ID, right? So now you can say that auto increment, when you are inserting values, you can mention only the name of values because the ID is you don't want to specify separately because ID is specified with the auto increment constraint. ID is specified with the auto increment constraint, so that auto increment constraint will arrange all the auto generated numbers for this tiger, dog, penguin, camel, cat, ostrich. So that how it is showing ID and the name. So you are applying auto increment to this ID column means automatically the name is what? Tiger, dog, penguin, camel, cat, ostrich. For this all the animal names, it is auto incremented with 1, 2, 3, 4, 5, 6. If you are specifying 6 values, it displays the IDs are up to 6. If you are specifying 7 or 8 something, it displays the auto increment values are 7, 8 like that. So the auto increment values are depending upon the inserted naming values. So like that you can understand this auto increment. Right? And the next constraint is what? Foreign key constraint. So foreign key constraint. So the key relationship between two tables can have relates with each other. So see here, this constraint is used to link two tables together. It is going to be showing that link for two tables together. It is also known as the referencing key. So foreign key is also known as the referencing key. So a foreign key column matches the primary key field of another table. So if another table contains primary key field, then a foreign key column matches the primary key field of another table. So it means a foreign key field in one table, refers to the primary key field of another table. That means the primary key and the foreign key are related to each other to displaying their table values. So see here how that foreign key how the foreign key refers to the primary key. We'll see here. The syntax is what? Create table persons. Person ID integer not null primary key. And the name varchar of not null constraints. So and age integer and the city is what? Varchar. So here I am specifying two constraints for the person ID as a primary key constraint and the name not null constraint. Right? That means person ID should be primary key. That means it doesn't have any duplicate and it contains auto generated numbers. that is nothing but auto incremented numbers. And for this, this is the table 1 and this is the table 2. So for this table 2, orders is the table name and the order ID is not null primary key and the order number is not null constraint and person ID is what? Integer. Person ID is what? Integer from this first table and foreign key of person ID. Foreign key is representing with the table 1 column references with the persons of table of person ID. So the second table is going to be referenced from first table. The second table is going to be referenced from first table. So the second and first tables are related to each other. Second and first tables are related to each other. So that what will happen? So that the table values which are going to be first and second is to be based on the person ID is going to be generated. Based on the person ID is going to be generated. So this is the way foreign key constraint is going to be generated. Foreign key constraints. So you can apply the constraints to the column level as well as table level. So to generating all the values, right? So this is what about the foreign key constraint, right? And so these are all the constraints we are applied here. So we'll see how it works and what we discussed in this session. So the constraints are applied for the conditions to the table level as well as column level. Table level as well as column level. Table level constraints as well as column level constraints. So table levels are nothing but what? Table contains all the columns, right? So table contains all the columns means you are applying constraints to all the columns. You are applying constraints to all the columns. That is nothing but table level constraints. But you are specifying constraint to single column, then it is said to be column level constraint. It is said to be column level constraint. So we can apply this column level constraints or table level constraints for these different types. We can use these different types to applying all the tables or all the columns values. So what are the different types of constraints? Not null constraints, check constraints, default constraints, primary key constraints, auto increment constraints, unique constraints, foreign key constraints, right? So if you want to specifying these constraints, if you want to specifying this all the constraints, not null constraints, default constraints, it should have the column name as well as it should have the data type also. It should have the column name as well as it should have the data type also. So then only the constraint is applied to the column. Constraint is applied to the column. So that is what we understand from this constraint. We understand from so not null constraints, unique constraints. It maintains unique values. Check constraint. It maintains the conditions based on the values that you entered. And default constraints, you are not specifying any values for particular column. It is taking all the default values. And primary key constraints, it doesn't allow us to duplicate values and it doesn't allow us to make an empty of the columns values. Auto increment values. So how if you are not specifying any IDs, it takes automatically of the increment of the numbers, automatically increment of the numbers. And foreign key, it refers to the second table from the first table or vice versa. It displays the values from the referenced table. It displays the values from the referenced tables. So this is all what we understand from this key constraints, right? So this is all about key constraints. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.